Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we will be using coordinate geometry. So let's get to it, shall we? All right, so there you see a little bit of an application with surveying and some geometry along with the Cartesian coordinate system. We just have one example today. We can use coordinate geometry to check the truth of geometrical fact and to prove geometrical facts. The biggies that we are using are the distance formula, the midpoint formula, and the gradient formulas. Remember, gradient is slope. And here is some powerful stuff. Equal gradients indicate that lines are parallel. And product of gradients, if that's equal to -1, it means the lines are perpendicular. For example, we know that if a line has slope of 2/3, a line perpendicular to it will have a slope of -3/2. So what they're saying here is if you multiply this, you get 2 times -3, that's -6, over 3 times 2 is 6, and that is equal to -1. That will always be the case when we multiply opposite reciprocals. And remember, opposite reciprocals are the slopes of two lines that are indeed perpendicular. All right, so this is our only example. Should be a short little lesson here. We got some points, and they are vertices of triangle PQR. M is the midpoint of PQ, and N is the midpoint of PR. So let's have a look-see here. Let's get a graph. Oops, did the wrong thing. So I'm going to do the stamp, bam, and we'll have a grid there. Okay, and let's go ahead and plot these. Okay, so P is at 3, -1, bam. If I could get the right ink thing. 3, -1 is P. Q is 1, 7, 1, 2, 3, 4, 5, 6, 7, and then -1, 5. So let's label this. P is 3, -1. Q is 1, 7. And then we have R at -1, 5. -1, 1, 2, 3, 4, 5. So here's R, and it's at -1, 5. Okay, we'll go ahead and connect those nicely. Get rid of the arrows, and we'll make it pink so it's a little easier to see. So we got triangle PQR here, and let's see what's going to happen with that. All right, so there's a triangle. M is the midpoint of PQ, so it's going to happen somewhere in here. And N is the midpoint of PR, that's right here. And so we want to find the coordinates of M and N. So midpoint M is going to equal, let's see, M is the midpoint of PQ. So that's the average of the X terms, 3 plus 1 over 2. And the Y terms, -1 plus 7 over 2. So that goes to 4 over 2 and 6 over 2. So that means that the midpoint M is at 2, 3. Let's check that out. 1, 2, 1, 2, 3. That works out swimmingly. So we have the point M at 2, 3. And then the point N is the midpoint of PR. So that's from here to here. So we're going to do that again. 3 plus, and this time it's a -1 over 2, because the x coordinate of R is -1. And then -1 plus 5 over 2. So that becomes 3 and -1 is 2 over 2. For the x coordinate, the y coordinate would be 4 over 2, which gives me the midpoint N of 1, 2. So let's have a look at that. 1, 2, perfect. That is point N, and it has the coordinates again 1, 2. Okay, so we've done part A quite nicely there. B, find the gradients of MN. So the gradient of mn is equal to y2 minus y1 over x2 minus x1. Remember, that's the gradient slash slope formula. So here's m and here's n, so that would be 3 minus 2 over 2 minus 1, which is equal to 1 over 1, or 1. Okay? And then let's go ahead and draw that line. Why not? They just asked us the slope of it. So I'm going to go ahead and draw it. Mn, slope of 1, which makes sense because it's connecting the opposite corners of one of the grid squares. And then they also want the slope of QR. So the slope of QR, I'm not going to recopy the formula here. QR, where, let's see, so it would be 7 minus 5 over 1 minus a negative 1. Oops, wrong parenthesis there. 1 minus a negative 1, which equals 2 over 2, which also equals 1. Okay, so the slope of this is 1 as well. So let's see what they ask us in C. What can be deduced from B? Well, the slopes or the gradients are the same, so we can deduce that since the slopes are the same, that line segment MN is parallel to line segment QR. Okay? D, find distances MN and QR. So let's see, the distance between M and N is going to be equal the square root of x2 minus x1 squared. This is the distance formula, plus y2 minus y1, the quantity squared. Okay, so I look to Mn, here they are. So that's going to be the square root of, let's see, 2 minus 1 squared plus the square root of the difference in my y's, 3 minus 2 squared, which equals the square root of 1 squared plus 1 squared equals square root 1 plus 1, sorry, equals square root of 2. Okay. And then they also want, let's see, QR. So let's see. Okay, so then QR, I'll do that, I'll squeeze it in over here. The distance between Q and R is going to be equal to, using the distance formula again here, let me block this off so there's no confusion. This is all part D here. So QR, different distance between Q and R, is going to be difference in our x's, so that's negative 1 minus 1 squared plus, let's see, 5 minus 7 squared. And that's going to equal the square root of negative 2 squared, negative 1 minus 1, plus negative 2 squared equals square root. Let's see, negative 2 squared is 4, negative 2 squared is 4, and 4 plus 4 is 8. Okay, and then with this, I can write this as square root of 4 times square root of 2. Let me put a little thing to separate this here. And the square root of 4 is 2, so this finally equals 2 root 2. So QR, Mn is root 2, and QR has a length of 2 times root 2. So I'll put E up here, and what can be deduced from T? It's real simple, and that is that QR is twice as long as Mn. And we have just proven, not proven, but we have shown an example of a particular theorem that says that if you connect the midpoints of two sides of a triangle, number one, it's parallel to the third side, and it's half as long as the third side. Okay, so that is it. Told you, one example. And we'll be back soon. And with that, I am Out.
Feeling as if I've been cursed, bitter cold within. Days go by and still I think of